As we all know, blast furnace process upsets are having a infinite problems. But in this presentation, we are going to talk here about a few process upsets and sharing the way outs. Coming to our first presentation slides, especially on the raw material. See, before looking into the process upset of blast furnace, it's quite essential. We must have to introspect our raw materials that is going to be charged in blast furnace. As you can see, sinter pellets are the prepared burdens and their properties requirements are of immense importance for avoiding any process upset of blast furnace. As you can see, in a sinter, RDI values are really very important, and any deviation in this property leads to generation of excessive fines. In the similar way, pellet are having a low RDA value, and if they have a bad swelling properties, then generation of fines increases several fold, and that too also if pellet is of acidic nature. Similarly, Lampur, poor reducibility backed with a high value of LOI are really very detrimental factors in deriving lower fuel rate in blast furnaces. So, understanding of our raw material that is going to be used in blast furnace need very important attention. Now, we will try to focus, or we can say we will try to put on a huge concentration on the burden level, as this illustration already shows that if our stock level goes down, really it generate a whole process upset link to the bottom of the furnace. Now coming to consequences of low burden level and causes effect on the process and corrective measures. Now coming to the causes of the low burden level, as all operators do have a quite good understanding that any delay in charging, slow filling, fast descent, or we can say a racing of the furnaces, or uncontrolled slips are the main causes of low burden level. Consequences of this level leads to high top temperatures, high CO2, or we can say bad utilization of the top gas, less volume for processing burden, optic temperatures as we have already mentioned on a higher side, and there is a distortion in the layer structure distributed at the top of the furnace. Then what next? What are the corrective measures in order to take care of this process upset? And these we can first of all make up by stabilizing the thermal condition of furnace, by fulfilling the fuel requirements. Because in order to find out a solution of such process upset, the most essential is thermal stability, and for that, if any fuel shortage is there, which is quite obvious, there will be a fuel shortage because the processing of burden is not normal, and hence we must have to back up the fuel shortage support to the blast furnace so that blast furnace remains thermal stable. Then our second priority will be restoring the burden level, and even if we fail to maintain the burden level, the next way out is reducing the blast volume. Now coming to the our next slide, where it illustrates mainly operate encounters most of the time where burden slips. And categorically, we can say that this burden slip are of especially four varieties, as we can see that there is a collapse of voidage and the burden level low, then also burden slip. There is a disruption in the layer structure which also leads to the burden slip. And important thing is about a jetting of the gas flow across the furnace wall, or we can say a partial symptom of channeling also leads to furnace slip. And this slip create a lot of asymmetric unalignment in the passage of gases, and it totally disturb from top to bottom layer structure, and hence is almost create a huge asymmetric condition in the furnace. Now, what are the consequences of slips when it occurs? As it has already mentioned, as the furnace is not processing the material in a normal way, the hearth gets cold. We have a bad utilization, as we have already mentioned, which is back up with a high top temperatures. Cooling trend is there. Thermal condition of the furnace goes down. And earlier we have already discussed, in order to cope up this cooling trend, it's very essential to make up the energy losses. We have to also recover the burden level, and if the burden level is difficult to maintain, then we can reduce the blast volume to get it fill up and to restore the normal layer structure. Many times, casting management also becomes a very important responsible factor in creating such type of asymmetric condition and slips. And in case of such cases of poor descent, our casting management, that is poor hearth drainage contribution, is to be taken by a better casting practices. In such cases, if we have a fluctuation of blast pressure, then we can also reduce and we can accord a soft blow. Two hot furnaces are also responsible reasons for poor descent and slips due to a very high upliftment of consumption. Too many fines in the burden also becomes a responsible reasons for poor descents. Now, one of the most important part where we were discussing about the casting management. Here, a picture just shown illustrated in order to see that how high residual liquid level is a responsible factor, is an important reason to have a bad utilization, higher optic temperatures, and thermal imbalance of the blast furnace. As you can show that due to presence of a more melt out around the bottom area of the blast furnace changes the cohesive zone and further gas distribution in the stack region of the furnace, which leads to a symmetric condition of the top temperatures, and this leads to a thermal imbalance of the furnace, and which further add on to a furnace slip and asymmetric conditions. Hence, in order to take care of such situations, it's uh, really needed that we should uh, focus on costing management in order to take care of such situation. Thank you.